Yeah. Okay, so what about this? There's a couple problems that come up. Pretty simple stuff, but I want to just make sure you guys understand this complex plane stuff. We went through it pretty fast. You might need to review this in the text a little bit or look at the PowerPoints. If we want to identify the graph of this complex number, let me make that a little bigger. How about? Okay, yeah. If we were to graph that complex number in the complex plane, what are the coordinates of that point?
8.
8, -5,
Yep.
right?
Yeah.
Because the coordinates of a complex number in the complex plane are just the ordered pair A, B, right? So A is 8, B is -5. So we would just go over 8, down 5, so it's E, isn't it?
Wait, that's it?
That's it, right? So it's E, that's all they want you to do here. Okay, but there's some other questions.
I was writing notes. Because I did not remember.
Yes?
What about when it has like the Z
In between the
That's what we're going to look at. Yeah, that's the next issue. Okay, so this one we've identified as E, right?
Yeah.
Okay, but what if they want to know something else? Or other questions ask you not just to identify it, but they want you to provide the magnitude. You want to find the modulus, right? How big is that complex number? So we know that the modulus is just the length of the vector in the complex plane. In other words, the distance from the point to the origin in the complex plane. So there's really two ways you can go about this that are equally good. They mean the same thing. If we're looking at it graphically, well, we're just going to turn this into a right triangle and use the Pythagorean theorem, right? That just becomes the hypotenuse of a right triangle. And what are the lengths of the sides of this right triangle? 8 and 5. And so the length of the hypotenuse then would just be, what, square root of?
A squared plus B squared equals C squared.
Okay, good. So the square root of 8 squared plus 5 squared, right? So 64, square root of 64 plus 25, right?
And this is to find the what?
That gives us the,
Hypotenuse.
right, okay, but what does that mean? That's the size of the complex number, right? If we wanted to compare the magnitudes, a lot of times, remember that complex numbers are used to represent real world things. Like a lot of times we talk about an example where they represent the impedance in a circuit. Okay, but if you get an answer back that the impedance in a circuit, the complex impedance is 8 minus 5i, what is that? Is that a big number or a small number? Because impedance in a circuit is measured in real units. It's measured in ohms, right? If you want to measure, you could get a little ohm meter at your house, and you could even do this. You could get a little test kit, and you could measure the resistance across your hand or something, or through a circuit or whatever. It's going to tell you a number. It's going to say, okay, the resistance is 25 ohms, something like that. Well, you got to know, so what is that? I mean, is that a big resistance or is it a small resistance? It's a complex number. It's not a counting number. And so it doesn't really tell us a magnitude. To find out what the numerical equivalent is, how big is that number, we've got to find out what the modulus is, right? So in this case, it would have been the square root of, what is that, 89? Okay. Whatever the square root of 89 is, so it's going to be 9 point something, right? That's the actual number that goes with that complex number, the magnitude, right? The size of it.
That then would equal the magnitude?
Yep, that equals
and
the
is
magnitude.
That what it's going to ask on the question?
Yeah, well, when it asks for the modulus, what looks like the absolute value, it's asking for the modulus, right? Okay.
Square root 89, is that the
So that'd be the answer. Yeah, question or comment?
So this is kind of about the distance formula pretty much just like another way to write Pythagorean.
It is. That's right. The distance formula and the Pythagorean theorem are completely equivalent. Completely equivalent.
So you could do the Pythagorean theorem instead?
Exactly. Well, and in fact, we have a formula. If we do our formula, okay, so if we want to come up with a formula here for calculating modulus, all it is the distance formula or the Pythagorean theorem, you know, it's either one of them. It just looks like it's always the square root of a squared plus b squared every time, right?
Yeah.
Okay. So now, there are some cases, the case like we just looked at was not difficult, but it was a little bit more difficult because it wasn't lined up on one of the axes, right? It was at an angle, and so we had to actually use the Pythagorean theorem. But what happens, sometimes we luck out. And if we wanted to find, for example, the modulus of negative 3i, well, where is that? You know,
Right there.
it's right there, right? What's the length of that vector?
3.
3, right? I mean, you can plug it into the formula, but it's kind of overkill, isn't it? If we want to find the magnitude, I get the square root of a is 0 in this case, right? 0 squared plus negative 3 squared. We would just make that a positive 3 squared, right? And so that's overkill. We don't need to do the square root of 0 squared plus 9 is 3. We can just realize that if it's lined up on the imaginary axis or on the real axis, it's just going to be the absolute value of that number every time, isn't it? Right? So it's just 3, yeah.
So the magnitude, if it doesn't have like a second part, is always the number in front of it.
Right, because then it's going to be a simple vertical or horizontal distance on the complex plane, and those are easy to
If it was
find.
like 6 with no eyes or anything,
It'd be
it'd
6.
just be 6.
Right, in fact, okay, what about that? So if we're doing, finding the modulus, you've done this a lot throughout your math careers, but you've just done a very small subset of what we're doing now. You've only dealt with situations where there's been no imaginary part, right? So if we're doing something like the modulus of negative 3, well, that's just 3. Isn't that just the absolute value of negative 3?
Yeah.
Okay, so it's not an accident that we use the absolute value bars for modulus, because in the case that it's a pure real number, the modulus actually becomes absolute value, right? Isn't that cool? How that's what you've done, but it's just a small piece of the puzzle, yeah.
So modulus will always be absolute value?
Well, modulus, kind of. I mean, it's written with absolute value bars. If it has an I in it, then it's going to be a distance in the complex plane. And so it's not. This is just. I feel like I'm talking and I'm trying to have a conversation with the group, and I always hear little pockets of chatter. If you have questions, raise your hand. I want to hear them, but do it in the group format. Yeah, so if it's got an I in it, it's a little more complicated. Then we really call it a modulus because it's a distance in the complex plane and it requires using this formula that involves A's and B's, right? But if it's only on the real axis, it just becomes what you've always known as absolute value. Yeah. Okay. Yep.
Wait, so will you go back to the other one, like with the cross star thing?
Was it this one right there?
Yeah.
Yeah. Mhm.
So what's the answer, like?
So the answer is, your answer would be, if they were asking for the modulus, it would be the square root of 89.
Wait, will you scroll down, please?
Sure.
What did it mean by those?
Okay, so well, see, this was an easier question. This just wanted us to identify which one corresponds to that imaginary number, and it's vector E,
Oh, okay.
Okay. right? Because of all those choices, that's the one that has coordinates +8, -5.
Oh,
Right.
okay.
Okay. Make sense?
Yep.
Okay. All right, on to some, I'm kind of excited about this. On to some cool stuff here. Let's see, so we did that. Yes, okay, let's look at quick review.
I remember this.
Quick review, yeah. Now on the quadratic formula assignments, there are 2 of them. The first one is the harder of the 2 you're going to find. I think they're all working. If you started it, like Delaney, you started it a long time ago, and so you're the only one I think that's got an error on that. That's a legitimate error. I think they're working now though. It's going to ask you to do 2 things. It's going to ask you to give an exact simplified answer, which is harder because it's got to have radicals in it then. Or on the second assignment, it just wants you to give only decimal answers, which makes it easier. Okay. So let's look at the harder ones. This is kind of the hardest kind of problem on the first assignment. If I want to solve this quadratic equation, this is where you guys need to start thinking big picture. Okay, now we've practiced a lot of little sub-skills, but now we're gonna take all those skills and we're gonna put them to work trying to actually just do something important. We wanna solve an equation. And so what would we do with this?
First, you need to
I
get a
added
positive.
Okay, good. Okay, good. We got a couple things here, 2 important points. We want to clear the fractions first of all, right? So let's get all the phones and everything away. I want to see just this is where we start. Got to start really going into engaged mode because we're getting into some harder stuff. So we want to first of all clear the fractions, and then we want to get everything on one side, right? I've heard, and we want to make a positive coefficient, a positive number. We want a positive coefficient of x squared. So right now, the way it stands, I've only got one x squared term and it's negative. And so if I were just going to try to muscle my way through this without clearing fractions, I would either have to add the terms to the right side, right? Agreed?
Yeah.
Or I could gather them on the left side and then
Divide by negative 1.
multiply or divide by -1 to change all the signs,
Well,
right?
Something.
Okay, but we've also got the added problem here that these are all fractions. And so if I want to do that, I'm going to be adding and subtracting fractions. I'm going to be putting fractions into the quadratic formula. That doesn't sound like fun, right? So we definitely want to do away with those fractions. Definitely want to do away with them if we can. And so we do that by multiplying through by the least common denominator, distributing it through both sides. In this case, what number? 8, right? But why not do both at the same time? Instead of multiplying by 8, why not multiply by -8, right? So we end up with a positive coefficient of x squared. Make sense?
Yep.
Okay, so let's do that.
Is it okay if we added the 1/4 first?
You could, but I'd recommend not because it's easier to add integers than fractions. And in this case, it was pretty simple. But what if those were like thirds and fifths and sevenths or something? Then it does get to be a little bit of a hassle, right? So you might as well clear the fractions first. Then you end up with only integer coefficients, and it's really easy to combine terms. Okay? So if we distribute the -8, now remember the little trick we always do. We know that we can always pre-reduce and then multiply because we picked this number to be the least common multiple of all the denominators, right? Yes, ma'am.
I have a question. So
Mhm.
since we multiplied it by -8 at the beginning, at the very end, we have to divide it by -8?
No, we don't. Because now, and a very good question, but think why that would be the case. This is an equation, right?
Yeah.
Okay, when we're solving an equation, if I multiply both sides of an equation by the same number, am I changing the equation?
Oh.
No, I'm not changing the solutions, am I? Right? Okay.
But if it was just like a statement without equals.
Then I would have changed things. You're right. Like if I were, for example, trying to find the graph of a function, multiplying by 8 would have changed the graph, wouldn't it?
Yeah.
Okay, that would be different. Oops, don't want to do that. Okay, so if I do this, come on. Oh. Okay, so if I distribute by -8, I can always reduce first. So what's -8 divided by -8? 1. So I can just multiply the numerator by 1 then, right?
Yeah.
And I know the sign's positive because it's negative times negative. I can always double check that. So I end up with just 3x squared.
Okay.
What about the next one? 8 over 2 is
4.
4. So I'm just going to multiply 4 by the top. Negative times negative is positive. Right? See what I'm doing?
Yeah.
8 over 8 is 1. So I end up with just
1.
positive
So just x.
1. Good. And on this side I would get what? Positive 2x. Okay?
Which would subtract it.
Right. Now we'll subtract that 2x. And we end up getting this into, what do we call this form when I write the equation equal to 0? Standard form. Good. Okay, so we get 3x squared plus 2x plus 1 equals 0. Okay, now we have to reevaluate. So we put this into a simplified standard form, which is very helpful. Now we got to figure out a strategy. Here's where the road forks. If we can, remember we always want to use the easiest method, which would be isolating x. Can I do that here?
No.
Can't. I've got 2 different x terms that don't combine, so I can't isolate x, which is unfortunate. Reversing PEMDAS is pretty easy. This is going to be a little bit tougher. Can I make this any simpler? Could I divide both sides by anything to trim it down?
No.
Nope. So I'm stuck. That's what I'm stuck with, right? Yes, sir.
Could you do the, oh, no, actually.
Okay. That's it. X equals that thing, right? Quadratic formula, the sum. What are you talking about?
Also, no, because
Completing the square?
+1 is 3 and it's equal. Never mind, just continue.
Okay, so now these are good questions. I think people are still maybe wondering, okay, what's our best strategy? Now, I've only got 3 options. I could try factoring, right? A times C then split B. What's the problem with that?
Takes forever.
Okay, it takes a long time. And what's the other huge problem with it?
You could mess up.
It might not work. It's only gonna work if this thing happens to factor. Now, what are the odds it's gonna factor in the real world? Not very good, right? So it's probably a waste of time. Why? Don't even try it. Yes, sir.
Can you do the matrix?
No, you can't. You can't. Now, what you guys are thinking of, the matrix method is for solving a linear system. Different thing, right?
Wait, what was it?
Well, that's if we had like 3 linear equations and 3 unknowns or something, right? Okay.
Oh, okay.
Okay, a little different. Okay, back up here, please. Okay, we could complete the square. That would work, but that's sort of hard, right?
2 divided by 2.
Wait, so why don't we do the song?
So we'll do the song. Absolutely. Okay, so get your voices warmed up. What do we got here?
X equals negative b plus or minus square root b squared minus 4ac divided by 2a.
Good, you got it. Okay.
You put 2 c's.
Very nice. Yeah, I got it.
Got a little excited.
Okay, so all we have to do then, this isn't hard. It's a little bit tedious. We have to just identify what are A and B and C, plug and shut, right?
Go.
Okay. So what's A?
1.
3.
3. What's B?
2.
What's C?
1.
Okay.
Oh,
I missed it.
So what's negative B?
Negative 3. I mean,
Negative
negative 2.
2.
Ow. Plus or minus 4 minus.
Okay, so
Minus negative 12.
4.
okay, how do we get 4?
Because that's b squared.
B squared.
Minus 12.
Okay, now one other question. B is 2 this time, right? What if B was negative 2? Okay, it'd still be 4. What if B was negative 3.154?
It'd still be positive, whatever that is.
Okay, then probably we wouldn't write that as a number because it'd be a horrible number, but we'd write it as positive 3 point blah 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 squared, right? If you have a negative 1 and if you have a negative B and you're going to write it as a number squared, you always write it as a positive squared, right? Positive number squared. Okay.
Wait,
Good.
so if you have like a long decimal, just write it as it's squared?
Yes. Right, because the decimal will get even longer if you squared it, right? Okay, so minus 4 times
3.
3
times what?
times 1. Okay,
Which would be
Negative
all over
2.
2 times 3.
Which is
Oh, it's 2A.
6. Okay? Okay, couple things. Now, to make this a little easier, we have a little trick. When I'm subtracting 4 times 3 times 1, how many negative numbers are there in that product?
it's an odd amount.
1, so that means that the sign of that product
Must
is
be negative.
negative. Okay.
So you're gonna get an I.
8.
Yes, we are. So we get x equals negative 2
Plus or minus.
square
Square root negative 8.
Okay, negative 8. 4 minus 12 is negative 8, right?
Over 6.
Over 6. Okay,
But we're not done yet.
we're not done. No, we're not done.
We are
2
We
not.
have a couple things, don't we?
5 root
times split. Yeah.
2.
Good
Good.
job, Jay.
Okay, good. So a couple things. Now we know that if I have a negative number under the radical, that's telling us
It's an I.
got an I, right?
This is not a real number.
Right. It is not a real number. Exactly.
Actually, like negative.
Yeah.
All numbers are imaginary. They're all minus. What if I just like drop this represents that? This is that. That represents that.
Okay. Here we go.
Negative 1/3.
Okay, so I'm going to get square root of 8.
Which is
2.
2I root 2.
Okay, good. We can simplify that. Over 6. Okay, now here's something that I just want to make you aware of. if I look at the specific directions for this, it's probably going to say something like provide exact solutions with all fractions reduced. It didn't say that you had to simplify the radicals, but you gotta be careful with this, because if simplifying the radicals makes the fractions smaller, then you do have to do it,
What?
right? I'll show you what I mean.
So just do it
So in this case, you would,
all the time.
because if I put it in like this, you're gonna get partial credit, guaranteed. You're gonna get partial credit. It's gonna say, nice try, but it's equivalent to the correct solutions, but they're not fully
That's
simplified.
why I haven't been getting them right.
Yes, okay.
I do not.
Now if, here's the kicker on this.
Mine was
If the bottom were like a 5, we could enter it just as two, as a plus version and a minus version, it'd be 100% right. But because that's an even number, and James was telling us he already reduced this for us, square root of 8 is 2 radical 2, right? So I could write this as negative 2 plus or minus 2 radical 2i divided by 6. Now I can factor a 2 out of the top and the bottom and reduce it. Yes, ma'am.
Okay, so I always put the I in front of the square root sign.
Me too.
Yeah,
Yeah, it's fine.
we
Sure.
can do it.
Is that better?
I mean, it probably, if you're writing it, it is. If you're doing it in Moodle with that equation editor, either way is fine, because you can see that the I is definitely outside of the radical. But,
And it's blue.
But it's okay if we keep it outside.
yeah, and it's a different color. It's blue, isn't it?
It is blue.
Yeah,
How
yeah.
do you do that?
Oh, magic. Okay, so then we end up with our two answers being negative 1 plus square root of 2i over 3. And I can split those into two fractions if I want. In fact, I think it even asks you to, doesn't it?
Yeah, 'cause this is A plus B.
Right, okay.
I did.
Okay, right, so you should
That's stupid though, I don't like that.
technically write that as negative 1/3 plus
Oh,
What am I-
no way.
that.
Do we have to do that?
I don't think it makes you, but
I disagree. It adds a lot more work.
That was way too stupid.
Kind of looks like a tree without like its tail.
Okay.
The whole bottom.
I'm not as concerned about that, but I do want you reducing the fractions. Okay, we good?
The effect
Yeah.
of that.
Okay.
Good?
Okay,
You're allowed.
almost, not quite. No, we won't get there today. I got some other important stuff. Okay, back up here, please. Okay, the second assignment. Second assignment is easier. It really is. Much easier. Here's why. Okay, on the second assignment, the questions are different. There's some questions that ask you to, the first few questions ask you to find the value of the discriminant. It should say discriminant. I think it says determinant. I'll change that. It should say discriminant. And then to use that to determine the number of solutions, and that's all it asks for. And I really, in a way, I almost wish I had just said, what's the sign of the discriminant? And not even asked you what the value is. Okay, I think I might change those, at least for next year. Maybe for the test I will. So, what does that mean, the discriminant? Now, if we were doing this problem, for example, we could approach this differently. It would have been easier to do, okay? We would have ended up with, well, okay, and then the second questions, I'm just kind of jumbled up. The second questions, the harder questions on the second assignment, quadratic equation assignment, just ask you to provide only real solutions. They say something like,
How many?
they say it again? They say provide real solutions rounded to the nearest 1,000. Separate your answers with a comma if there's multiple solutions. But if there are no real solutions, just enter n. So if you get i's, you don't even have to write them down.
Oh, that's so cool.
So then we
Right.
like eyes now.
So then you like i's. And those are kind of real world type problems. A lot of times you only really want to have real solutions. For example, if you were, let's say you were trying to find some real world thing, like you were trying to figure out, let's say, if I shot some projectile, when's it going to hit the ground? Something like that, right? Okay, if I get answers that say something like 10.3, that makes sense. 10.3 seconds it hit the ground. But if I get answers that say something like, 10.3 plus 5i, well, that doesn't make sense as a time, does it? So those wouldn't have any real meaning, and we would discard those. And so that's what those other questions are kind of preparing you for later on in engineering and math and science is you keep the real solutions and you discard the imaginary ones. Yes, ma'am?
So if we got this answer instead of putting this answer in, we
N, exactly. Okay, but this brings us to the discriminant. Okay, the discriminant, if we go back one step here, when you're doing, solving quadratic equations, especially when you're only looking for real answers, it really makes sense to pay attention to the value of the discriminant, or at least the sign of the discriminant. What does it mean to discriminate?
To
Some
go
people-
inside.
Okay, well, kind of. If I'm going to discriminate between two things, judge something based on differences, right? So I could even say something like, I'm going to discriminate between those two kinds of steak based on flavor and whatever, et cetera, right? And then I'm going to pick one based on the differences. That's what it means to discriminate. And it has negative connotations if you're talking about people instead of like steaks or chocolate bars or whatever, right? But anyway, that's what discriminate means. It means to pick something based on choices. So the discriminant in math is asking you to make a choice based on the value of something. And it's a good choice. We could have said here, so the discriminant really is just this thing right here. Right?
Yeah.
It's just the b squared minus 4ac in the quadratic formula because that's the part that's underneath the radical. Isn't that the part that's going to determine if you have i's or not? Right? So if we start with that, if you always start in the quadratic formula with the b squared minus 4ac like we did, when we get an answer that we don't even have to know what the value is. At this point right here, 4 minus some relatively big number is going to be negative, isn't it?
Yeah.
We can stop. We know right away that the discriminant is negative, which means I get no real solutions and 2 imaginary solutions, right? And you know to quit. So there's no point in even setting this whole thing up. You just start with that number and see if you're going to get real solutions at all. And then if so, you got to do the problem. If not, stop, right? See my point?
Yeah.
Okay, good. Yes, sir.
Would it be possible for like one equation to have one real answer and one imaginary answer?
It's not, and we'll talk about that next chapter. Fundamental theorem of algebra makes that impossible. And I'll tell you real quick, the reason why is because complex solutions, imaginary solutions, always come in complex conjugate pairs. So if you get, for example, if we get the answer, well, what do we get for our answer? If we get the answer negative 1/3 plus square root of 2 over 3i, guaranteed you're going to get negative 1/3 minus square root of 2 over 3i. It's not an accident that these are always just a plus and a minus is the only difference. It has to be that way, okay, when you look at solutions of polynomials. Okay? And we'll talk more about that next chapter. So then all you have to do on the second assignment, if you want decimal answers, is pretend that, it's for the sake of argument here, pretend that this was a positive 8, not a positive 8i, right?
Yeah.
All you would have to do is plug this into your calculator, get a decimal answer, right, for one of your solutions, then just go up in your screen on your calculator and grab this expression again to edit it and change the plus to a minus, hit enter, and you get the other answer, right? Make sense? And you just want the decimals rounded to 3 places, I think is what I asked for. Okay, so next issue. Next issue. Now, here's the last stuff I want you to be familiar with. I really like these. These are cool. I'm very proud of these problems. Okay, so there we go. Okay, this guy.
I finally took the last.
Okay, I want you to think strategically here. I'm going to give you some problems like this. Okay, I want you to write this quadratic function, this graph here, in general form. Now take a second, don't say anything. Everybody take a second, look at this, consult with your neighbor, see if we can come up with a strategy. Standard form, same thing.
Oh.
And you know that if you click on these things,
It doesn't usually do that.
What's it usually do for you guys?
Nothing. You click on it, it doesn't do anything.
Oh, yeah, that's only if there's a link to it.
Yeah.
The links won't all be there until
Because
next
I
year.
tried to
But
play the song again and it says it doesn't allow it.
if you click it twice, it will.
Because I did it and something popped up and it said I do not allow this.
Really? Yeah, those may not be there for you. Next year they'll be there. This year I may not have them. Anyway, suggestions.
I have no idea.
X squared plus 4 plus
Well, we
1.
know
So
the
the
vertex.
It's a vertex. Wait, that's so not right.
Okay. Okay, now let me get your attention up here, please. Okay, look at this. Okay, so there's something interesting going on here, because you can solve this problem. Normally, we would say, and I want you to think back to a pattern that we discussed earlier in the year. How many points does it take to define a line? 2. If I have 2 points on a line, I can always come up with the equation of y, right? How many points does it normally take to define a parabola?
3.
3. Okay, 3. It's a more complicated thing. We need an extra parameter in there, so we need normally an extra point. But we can do it with 2 here. How come?
Because it's on the y-axis.
Symmetrical.
Because it's
Okay, good. And there's really the hidden reason is because we're taking advantage of the symmetry of the thing. What we've really done is we've dragged 2 points down so that they overlap on the vertex, right? The reason that we normally need 3 points is because if you think about the number of parameters in all of our quadratic functions, they all required 3 numbers, didn't they? A, B, and C in general form, A, H, and K in vertex form, A, P, and Q in vectored form, right?
Oh, it's always A.
And so because we need 3 values, normally that would require us to have 3 separate equations. But because this happens to be in a special form, because it happens to be, we're given the coordinates of the vertex, think about this now. What is vertex form? Vertex form is y equals A times
X minus
squared plus, okay. The coordinates of the vertex here are what?
-4 and 1.
Ah, okay. That's giving you, in 1 point, that's giving you 2 of your numbers, your parameters, right? So if I plug those in, don't I just get y equals A times x minus -4, so x plus 4 squared
I'm +1.
plus 1?
Yep.
Okay? Took care of 2 of them. There's only 1 other parameter I need, right? A. So the question remains then, if I want to, and wouldn't you agree that if I could get this into vertex form, pretty easy to change that to general form, isn't it?
Yeah.
Doesn't that just mean I'm gonna expand out this square? So FOIL it out or use an expansion formula, just x plus 4 times x plus 4. Simplified. If I knew what A was, I could just distribute that through and then add 1 to the constant and I'm done, right? But I need A. How am I gonna find A?
Isn't it the slope?
Okay, so there's a couple answers to this. And in some cases, we can use the up and over trick, right? So we go over 1 and it looks like we go up 1/2. So A would be positive 1/2, right? Okay, but what if that's not 1/2? Because it doesn't show up in a convenient place, right? It might be 3/8. We wouldn't be able to tell the difference probably, right?
Go over until you get to a new.
Okay, so there is a trick for that too. I'll show you that trick, but then I want to give you a foolproof method also. This is all good stuff though. So make sure, see if you can make sense of this. Now, if this were a normal parabola, if we look at the parabola, for example, just y equals x squared, I want you to tell me some things about this, right? If I scoot over 1 to the right, if x changes by 1, how much is y going to change by? 1. By 1 squared, right? So normally, on a normal parabola, I would go 1 to the right and up 1, correct? On a normal parabola, if I go 2 to the right, how much up should I go? 4. 2 squared, right? If I go 3 to the right, I should go up 9, etc., right? So what we could do is we could pick a more convenient point like this one right here and say, okay, now to get to that one, I'm going to the right by 1, 2, 3, 4. So on a normal parabola, I should go up 16. How much do I actually go up?
9.
I go up 1, 2, 3, 4, 5, 6, 7, 8.
Wait, I'm so confused right now.
It is.
So it is 1/2. Okay, because we're just going to look at the fraction. Listen, please. We're going to try to decide what is the fraction that this is increasing vertically of a normal parabola. A normal parabola, if a were 1, we would go over 4 and up 16, right? But because we're going over 4 and only up 8, that's only half of what we would normally go. And so a, we must have multiplied by 1/2, right? So a is 1/2. And that way we can even get complicated values, like what if instead of going up 8, we went up 7? Then a would be 7/16, right? Okay, so that's a pretty tricky way of doing it. Even that is sometimes going to fail. Sometimes that's going to be, I mean, that pretty much, that's going to just about always work, but even that could sometimes fail. What if we had another coordinate up here, for example, that was a decimal, that wasn't even an integer value? Then that's really not going to work well, is it? So in this case, we have this other ordered pair, 0, 9. How could we use that and solve for a without taking advantage of any of these visual tricks? What do you think?
Plug it into the equation for
Yeah.
x and y.
Absolutely, because now think why. I want you to kind of start putting this all together. This is the like lights come on at this point in the class a lot of times. And this is, so 0, 9, this is a point on the graph, right? A point on the curve. And so it must represent a solution of this equation, right? If it's a point on the graph, it's a value of x and y that satisfy the equation, right?
Yeah.
So I should be able to plug 9 in for y and 0 in for x. Agreed? Right?
And then just.
And now I can solve for a. Isn't that cool?
Oh.
Right? So we end up with,
9 for what?
for y, because that's the y coordinate,
And that
Right.
can work for any point?
works for, yeah, any point.
Okay.
Doesn't have to be anything special, as long as I have a second point on the graph. If it's on the graph, it's a value of x and y that must work. It's a solution, right? So if I plug those in, I'm just going to get 9 equals a times the quantity 0 plus 4 squared plus 1, right? So I'm just going to get 16a equals 8, right? So a is 1/2, right?
Wait, why 17?
17.
Plus 1.
The 1's outside though, right? So I subtract the 1 and make that an 8, divide by 16 and get 1/2. Yes?
Oh,
What if there were 3 points on the graph?
Then we wouldn't even need them all. In this case, if one of them is the vertex, we only need one other point
Wait, you said it's 2a times this, right?
Yeah.
To find a, right?
to find a, yeah. This way, this is the way. This is the way you actually find a that's always going to work. It's a very general method because it worked even for non-polynomials. This could have been a square root or an exponential function or anything like that. If I have one unknown and I have another point, I can always plug in another solution for x and y and solve for the unknown, right? Yep.
So when you did the first way, does it have to like hit the y-axis, like the 9 up?
It wouldn't have, no, the point could have been right here, for
And
example.
then you
Say-
just.
Then I would have just said, does that make sense?
So it was just.
Then I'm going over a certain amount and up a certain amount.
So it's just like coincidental.
Yeah. Exactly. Total coincidence, it's on the y-axis, yeah. Okay, so another one. Does that make sense?
yeah.
Okay? And then we could just, once we know what A is, we could just expand this thing and simplify it, and it puts it into general form, or standard form. Okay, what about this one then? Tell me how you're going to do the same kind of thing for a slightly different problem.
Okay, so holy cow.
So much.
Yeah, but we're on the 3rd floor.
Did Ellie just say Santa's on the
Okay, what about this one? Okay, hold up. Okay, real quick. So now, this time, what if we want to write this in, it asks for factored form, but I'm going to give you another one on the assignment that's going to ask you to do the same thing for general form. Really, it's the same issue. Okay, what's the form that this one fits very conveniently?
The one that we just did.
Vertex.
The one where we get the zero, so factored form, right? Okay. Is that us?
Yeah.
Okay, we'll finish this up.
Are you
Next time.
guys here tomorrow?
Yeah, for at least a bit, and then we'll head down. Then we'll be done with the chapter.
I thought you had one little assignment left for us.